So if you want to get comfortable, do whatever you want here. And talk us through it, okay?
For the first one, to convert degrees to radians, you'd have to multiply 120 over 1 times pi over 180, and that's simplified with that would be 40 pi over 60, and simplified that would be 2 pi over 3. And then for number 2, we already know that 180 in radians is pi, but to do the work, it's 180 over 1 times pi over 180, and that cross out, so that equals pi. And then we do the same thing for number 3, and you get 5 pi over 4 simplified. And then it's the same thing if it's a negative 30 over 1 times pi over 180, and that would equal negative pi over 6. And then for this one, you need to find r first, and that equals x squared plus y squared. So that's 2 squared plus 5 squared. I'm going to get 5 squared doesn't matter. That would be 4 plus 25, that equals square root of 29. And then sine equals y over r, cosine equals x over r, and then tangent is y over x, and then that would equal negative 5 square root of 29 over 29, and that would equal 2 square root of 29 over 29, and this would equal negative 5 over 2, and then the other 3 are opposite, which would be r over y. And this is r over x, and this is x over y. So simple.
Let's see. Just to check, were there any? Do you have the signs on those ones as well? You have the negative values for the ones with the y in it,
Yeah, negative 5.
and then on that one.
That one's a negative.
Okay.
It's like a dot.
Looks good.
This looks nice.
Okay. Any questions for Redia? Thank you, Redia. Nice job. Okay. Only small thing I would say about this one is it's fine to think of these in your head as writing just sine equals this, cosine equals that, cosecant, secant equals that. But when you communicate it on paper to somebody else, these are functions. And so make sure if you're writing it down on paper for me, you're ensuring that you put this sine of, this is important. We're doing sine on some angle theta. So make sure you have that in there. Okay? All right, so nice job. So before we get started today with 13.4, which is inverse trig, you really need to pay attention today, so if you don't have your stuff out and you're not ready, it's going to be tough. 13.4. So, before we get started, regarding the test, would you want to be on that Ferris wheel?
No.
No? Why? What was wrong with the Ferris wheel? How many feet per second? I know there was 2 different versions. How many feet per second did yours go? Really quick, right? So, don't go to that carnival. All right? It wasn't supposed to be a take-home test, but, well, that's what the sub said, so I guess we'll just listen to him.
Are you gonna give us like another test before the quarter end?
No, this was the last one, so you're going to have some homework and stuff to turn in next week, but no more assessments. I think it'd be smart, so I'll probably assign something so you don't forget it. Yes, I
How
will.
would you do that?
Guys, a week is a long time, right?
It's
Yeah.
called break
I know.
for a reason.
I know. I'm just saying a little bit. Yep.
On the test, you didn't put data or you did points on all of them?
Yes, I'm going to grade strictly because you were able to take this home. So I expect if you take it home and you have all day to do it, I expect perfect work, or I should say your perfect work. However, your best work, that's what I will see, and I'll grade it knowing that it's your best work. So yes. That's fair, right? Yeah.
If like the majority of your class you do every single take up that position.
Yes. Math doesn't change. All right. So, objectives. Evaluate inverse trig functions. So you should probably write this down, what our goal is for today. Evaluate inverse trig functions. I already put it on the board. Okay. Use trig equations and inverse trig functions to solve problems. We'll probably only get to this today. But, and I know you've used inverse trig before, but do not tune out because there are some real subtleties here. And if you try and blow past it, you're going to miss them all. Alright? So, you've done some of this before. Inverse trig. You used inverse trig to do what? What do you use inverse trig for? These help us find measure of angles, right? So if you don't know what they're used for, you need to write that down. Inverse trig used to find measure of an angle. And you've used it before, but you've never talked about it as a function. Okay. So, you should write down these relations and know why they exist. Function and its inverse relation. So, do you remember what functions and their inverses do to each other? They undo each other. Okay, that's totally unacceptable. They undo each other. So, for example, Caden, if I tell you x cubed, what's the inverse of x cubed? X squared? No. So what undoes a cube? A cube root. If you have a square, what undoes a square? Square root. If you have a sine, what undoes a sine? Sine. Everybody's going to say it. Sine inverse. This one, and yeah, you can call these arc, right? This is arc sine, arc cosine, arc tangent. So that's good language. While you're writing this down, I want to point out that this is different from, for example, is this the inverse of 5? It's the multiplicative inverse of 5, but it's not a function. This is just 1 over 5, right? This is not what we're doing today. Sine inverse is not equal to 1 over sine. We already have a name for 1 over sine. What is it? Cosecant. Okay? We already have a name for this. So this is something completely different. This is inverse. And it undoes sine. Okay? Just to give you a quick idea of the algebra of why this is true, if you want to undo the sine, well, you do sine inverse to both sides, sine inverse to both sides, and then you arrive at theta is equal to sine inverse of A. So if you're not good with that algebra, I mean, that's all it is. To undo sine, use sine inverse. Whatever you do to one side, you do it to the other. Some of you must be experts because you're not taking anything down. It's very good. All right, reading math. Sine inverse. Right as the inverse of sine, we already talked about that. Okay. Now this, Morgan, put it away and I want you to read it. Read it for us.
The inverses of the trigonometry functions are not functions themselves because there are many values of theta, a particular value of A. For example, suppose that you want to find cosine inverse 1/2 based on the unit circle, angles that measure pi over 3 and 5 pi over 3 radians have cosine of 1/2. So do all angles that coterminal with these angles.
Yep, so good. We're going to have to restrict domains here today because if you look at this, and I want you to really pay attention to this, look at my finger and listen to what I say, okay? Cosine inverse of 1/2, what that is saying is find me the angle that when you take cosine of it, you get a value of 1/2. So I'll say that again. Yes, so this says cosine inverse of 1/2. What that really is telling me in my head, what angle theta, such that when I take cosine of it, gives me a value of 1/2. Does that make sense? If you look at the unit circle, Mary, what angle, when I take cosine of it, will give me a value of 1/2? This is why I'm saying you need to listen today. It's on the board. Cosine is x or y? X. Cosine of what angle will give me an x value of 1/3? Or sorry, 1/2. It's on the board. Pi over 3. There's also another one. 5 pi over 3. Look, x value, 1/2. Okay, there's a problem there. You can also do infinitely many of these. If I take this and I add 2 pi to it, won't I be back at the same place? Or if I subtract 2 pi 100 times, won't I be back at the same place? And I will always have this x value of 1/2. You have to be comfortable talking about radians and degrees. So for example, pi over the 3 is the same thing as how many degrees? Pi over 3, same thing as 16. I think it's going to be best to talk about radians, so that's what I'm going to prefer to do. So, now let's practice a little before we start restricting domains. This is an important example that I don't think you've seen before, is finding all answers for a given problem. When they say find all, you're probably going to have a lot, right? Yep.
Yeah.
So I want you to find me I want you to find me 2 answers for this first one. And I'll zoom in here so you don't get overloaded. Find me 2 angles. Actually, you read it up to me. What are you looking for this problem?
The angles with the cosine of -3.
Angles such that when you take cosine of it, you get a value of -√3/2, right? Can you find me those angles? Yeah, look on your unit circle. Let me demonstrate it. I want you to find me 2 using your unit.
240. No. Yeah, no.
I want to hear radians.
7 pi over 6. 7 pi over 6. 5 pi over 6.
So you shouldn't have any kind of calculator out right now. You should only consult your unit circle. Only should be consulting your unit circle.
7 pi over 6 for 11.
I heard 7 pi over 6.
5 pi over 6 is 7 pi over 6. So, because it's cosine first, so you find everything that equals 2.
Did somebody say 5 pi over 6?
Yeah.
Yeah.
7 pi over 6.
And 7 pi over 6? Both of those definitely will work because if you have the unit circle either in your hand or in your head, I know that x value is negative root 3 over 2, so I know it's the farther one out, and I go up a little bit. And yes, I know that's 5 pi over 6, yep. And this one has the same x value, and let's see, this was 6 pi over 6, so this must be 7 pi over 6, yep. X values there are negative root 3 over 2, good. And now, let's put that down. Let's put down those angles we found. Theta can equal, let's see, 5 pi over 6. And theta can also be 7 pi over 6. Now, here's the trick with finding all answers. Coterminal. Don't both of those angles have coterminal angles? Yep. They have infinitely many of them. How to find them? Well, if you start here, it's 5 pi over 6. How much do you need to add to get back? 2 pi. So, if you take any multiple of 2 pi and add it to your answer, you will be right back where you started. How to write that down using math? You do this. 5 pi over 6, and in pink I will write this, plus 2 pi times multiple. Some multiple of 2 pi. Could be anything, but it can't be a fraction, so we have to account for that. Well, say that k is an integer. K is an integer. So give me examples of what k could be. K is an integer. What are you looking at? K is an integer. So this is reading math. K is an integer. K is an integer. Tell me an integer. 2. Negative 5. 3. Right? Aren't those all, if you put them in here, won't this still be a multiple of 2 pi? 2 times 3 times pi, that's a multiple of 2 pi. That's 6 pi. If you add 6 pi to that angle, will you be right back where you started? Yeah. I have to also say the same thing right here. If you take 7 pi over 6 and add some multiple of 2 pi, so I know you haven't seen this notation before, but that's why I'm introducing it, so you learn something. K is an element of the integers. K is an integer. 1, 2, negative 1, 2, any number like that, 0. Right? All of those are integers. No fractions, right? Mm-hmm. Okay, do you want to do one more together? Let's try one more. And these visuals here will be very helpful. So if you start drawing the unit circle, that'll help you not only in this class, but in pre-calculus. So somebody explain to me in words what number 2 is asking me for. So I'm going to keep saying this over and over again. Who's got it? Give it a try. Hold on, I got Everett here.
It's like what angle such that tangent of that will equal 1.
Right. And here's a way to show yourself this so you can, and very nicely put. This is equal to some angle, right? Inverse trig is used to find angles. Well, how to get rid of tangent inverse? What's the opposite of tangent inverse? Tangent. So do tangent to both sides. This might help you. Cancels. 1 equals tangent of theta. So again, going back to what Everett just said, tangent of what angle theta would produce me a value of 1. what angle theta such that when I take tangent of it will give me a value back 1?
In radians,
Well, it could be radians, could be degrees. I would like it in radians.
pi over 4.
Okay, that's one of them. There's also another one. 1, 2, 3, 4, 5. Yep. The two answers are definitely theta equals pi over 4. Hold on one second. Let me draw myself a picture for those of you who are visual. Pi over 4 is right here. 5 pi over 4 is right here. Now, the x and y values for both of those are what? For pi over 4, it's square root of 2 over 2. Square root of 2 over 2. Over here, it's the same values, but just negative. So, remind me again, I forgot. What's tangent? How's it defined as? If you divide this by itself, won't you get back 1? If you divide that by itself, won't you get back 1?
Yes.
Yes? Here's how, yes? Say it again. Oh, no, because I know you see the 1 there, but look, it's y over x, right? Here's pi over 2. 1 divided by 0 is what? Undefined, right? You can't divide any number by 0. So it's a good try, but unfortunately that one, no, doesn't work. These are the only two that, yep. Put your hand up. 45, and whatever this one is 180 plus, so that's 225. Now, hold on one second. You don't have to do 2 cases this time. How much do I have to add to this pi over 4 to get me to that 5 pi over 4? You have to add pi, right? So look, here's how you're going to write your answer for this one. There's only one answer. All right, theta is, pick either one of those. Which one do you want to pick? Okay, pi over 4, if you add a multiple of pi, and that multiple is an integer, won't you get back to the other line? No, the other one would not have worked. The other one would not have worked. I'll show you why in a second. If you start here and you add pi to it, won't you get here? Or if you start here and you subtract pi from it, won't you get here? If you start here and you add 3 pi to it, 1, 2, 3, won't you get there? Yeah. If you start here and you add 2 pi to it, 1, 2, won't you get back there? So do you see how this one line accounts for everything? Say yes, no?
Yes.
Yes? If not, yeah. Why doesn't it work for the other one? Take a look at the picture. If I start here and I add pi to it, where will I be? Over here. So you see that? So that's why it doesn't work. It only works if they form a straight angle. Oh. Yes, because I want you to, this only accounts for 2, and there's no reason to write it twice if you can write it once. So, yes. Just know that if there's a straight angle, you can just take the angle and add pi to it. N, what is it? N is what? It is not a number, don't say that. It's a specific number. That's not right. You said it's a number? Okay, it's 1/2. You said it's a number, it's 1/2. Let's check if that would work. Because some of you seem to disagree with me. You said it's a number? Pick 1/2. Well, that only gets me to right here. You cannot say it's a number. You have to say it's an integer. Okay, so you try one on your own, because we're only practicing this and maybe... It's the same thing. These are just dummies that I picked. I could have called them M. I could have called them C. It's just a dummy. I can put any integer in there.
Just a variable.
So just to clarify, you just choose a random letter.
Yes. Yep.
So
Yep.
you have to use like either or depending on like the
Yeah. If it forms a straight angle, can you write it in one line? Yes. If it does not form a straight angle, can you write it in one line? No. It's as easy as that. So you try it on sine. This one says sine inverse square root 2 over 2. You tell me the answer for that after you take a minute or two. If you need a help, let me know. In words, I'm looking for the angle theta such that when I look at the unit circle, the y value is square root 2 over 2. Angle theta such that when I look at the unit circle, the y value is square root 2 over 2. Draw myself a picture. Square root of 2 over 2 only happens in two places for the y value. Right here, and does it happen right here? Nope, that one's wrong. Does it happen right here? Nope. Happens right there, right? Well, what are those values? Those are in terms of fourths. This is pi over 4, 2 pi over 4, 3 pi over 4. Pi over 4 and 3 pi over 4, correct? Can you write it in one line? No, you have to write it in two. So my answer's theta equals pi over 4 plus, give me a dummy, I don't care. X times pi, 2 pi. And you're going to say that x is an integer. The other one we didn't talk about yet is right there, and that one was 3 pi over 4. And just use the same dummy. X times 2 pi. X is in the integers. You need help? You good? Good? Yep.
Is there ever a case where it's not like pi or 2 pi, but it'd be like pi over 2 or something like that?
Yeah, but we're not going to talk about those right now. I want to keep it nice and easy so we don't scare anybody off just yet. Right? We're going to be pi or 2 pi. And you?
Is it 2 pi because it's 2?
Say it again.
Is it 2 pi because it's 2?
Well, you're right that it's two different ones, but wasn't this one also two different ones? It was this angle and this angle, right? It's 2 because do they form a straight line? No. If they form a straight line, you can use one line. Hey, that actually works pretty nicely. If they form one line, you can use one line. If they do not form one line, you need to use 2. Make sense? Okay, so now you should be good with that. Talked about restricting the domain. This is the important piece of the day. And this is one of the last things we'll do today. Yes, definitely need this. And the fact that S, C, and T are capital is intentional. S, C, and T are capital for a reason. It didn't show up for the one. Okay, so why do you think they're capital? What reason do you think they're capital? Because we have a domain restriction. So if you see capital, it means that they're restricting the domain. You don't have to memorize these. I would give it to you if we have an assessment, or when we have an assessment on it. Should be a line there. But if you take a look, when we do inverse trig, we're going to restrict sine to the, I don't know, I guess what would you say? That's the eastern hemisphere. If you look at cosine, we restrict the domain to the northern hemisphere. And when we look at tangent, we restrict the domain of tangent to the eastern hemisphere. Okay. Yep. Well, the reason why we restrict it, we'll show you a picture. Let's see. Does everybody have this copy down? I'll just do a visual on the board then. Okay, sine or cosine, either one, they look like this, wavy, right? And they go on forever. If you look at their inverses, y, x. If you look at their inverses, does anybody remember when you look at the inverse graph, so this one, let's just say it's sine. When you look at the inverse of a graph, something special happens with the y and x values. What happens with them? You flip them, right? Remember we solved using inverses, and we had to switch x and y, and then do some algebra, and then solve, right? And then we would say f inverse equals this. Remember when we did a unit called finding the inverses of a function? Yep. We did that, and one thing you did is you switched the x and the y's. Do you remember doing that? Yep, that was one step. Well, here's what would happen. If you switch the x and the y's here, this is what this graph would look like now. Is that a function? No, because it fails some test that you've learned called the vertical line test, right? If you draw a line through a function or a curve and it passes through more than one point, is it a function? No. So that's why you have to restrict the domain, Evan. That's why you have to restrict the domain. Okay, so if you restrict the domain, this won't happen. Okay, so that's the answer to your question. That's why you have to restrict the domain, so that these trig, inverse trig functions are actually functions. Okay. I guess, I don't think I wanted to do any of this, but I would like you to do one thing before we do a little one problem CFU.
This was one question.
Sure.
Would you applies to the problem like stating the domain range, or like
Yep.
what's this for?
All, it's for something. I'm not telling you it for no reason. We are going to use it, but we have to build it up. It's too much information for me to just put down on the board and say, copy it all down and now let's use it. We have to take our time with it. And if you're not paying attention, or doing something else, you might miss it. So here's what I want you to do. I gave you the domain for these restricted functions. You tell me the range for them. Tell me the range. This talks about the inputs. You need to tell me about the outputs. What values can I get out? See if you can do that. You can look at your unit circle. This is the domain. If I plug any of these values into my sine, what value can I get out? And tell me the range of them. Yes. Mm-hmm. Where are the values you can get out from these function sine? Well, It's all of the y values, right? Isn't it all the y values? If I'm only talking about this region, what's the lowest y value I can have? -1. What's the biggest y value? Not 0. 0 happens here. 1. 1. No, it's good. I like the participation. -1, 0, and then 1. So the range, I don't want to say x and y to confuse you, so I'm just going to pick another dummy, call it lambda. Okay? -1 and 1. These are the values you can get out from this function. Do you agree? It's on your unit circle, right? Down here is -1. Up here is +1. Does that make sense? Yep. We're looking at the points.
Wait, what other side? What
Are we talking about the other side?
Yeah, but like if it was the other side, what would it be?
We are choosing to restrict our domain. It would be the same thing, actually, because -1, 1. Well, this is actually because you restricted the inputs. Think about this. If I restrict the inputs, didn't I necessarily restrict the outputs? Think about it. If you restrict what you can put in, didn't you just restrict what you can get out? Yeah. Mm-hmm. Nope. You just have to be able to state the range. So if I give you this, you have to be able to state the range. All right. So don't worry. It's good. It's good questions. What is what? I just said this like 3 times. The range, you look for sign. Is it the x or y values? Look on this hemisphere, on the red line. Aren't these all the x, y values? What is the lowest y value you can have? It occurs right here. What is it? -1. What's the biggest one? 1. Everything else is in between there. Agreed? And that's exactly what this says. Okay, too much. Running out of time. Cosine. Guess what? What's the range on cosine? Okay, what are all the x values for cosine? From -1 to 1. Guess what? It has the same thing. And that's a good question. Do they all? The answer is no. Think about it. Tangent is y over x. Imagine this in your calculator. Grab your calculator out. So this is a good technology application. Tangent is y over x. Give me a number that you think maybe the y value is for that green point. What do you think the y value is? It's on the line. No, it's not 1. 1 would be at the tippy top. So 0.99. Maybe that's y, right? Okay, what is the x value? Is it big or small? Look right here, right? It's really close to 0. So give me a super small number.
0.01.
Maybe call it 0.01. X value is 0.01. Divide y by x right there. Divide y by x, because that would be tangent of that angle. What number do you get? You get a really big number. You get 99? Okay. So, tangent. You probably believe me, hopefully, after that. Tangent can go anywhere. Tangent can be anything. Think about it. If you make y super close to 1, let's say it's 0.99, what happens if you keep dividing by that something closer and closer to 0? It gets bigger and bigger, right? That's why you have a range that can go from -infinity to +infinity. Yep.
What's negative infinity?
It would just be on this side. Get real close to -1 for y, and get really close to 0 for x. And then that'd just be, yep. No, that is evaluating tangent. That is evaluating tangent at that angle, which is almost 90. The angle, if you look right here at my hand, maybe it's like 89.999, right? So this is the ratio between the two legs of that triangle that we're talking about. The triangle that we're talking about, if you created this triangle, remember, you have to remember back to what these trig functions actually are. They're talking about a triangle. What kind of triangle? A right triangle, and it's the ratio between this leg and this leg, right? That's what tangent is. Does that make sense? Yep. Sure. Oh,
So
question.
we do need to state the domain for the tangent. Can we just do x is equal to is such that all real numbers?
Yeah, you could say, for example, maybe don't use x or y. Maybe just pick a different one and say that variable is an element of the real numbers. Okay. Well, that was long, but it's a lot of conceptual pieces today that we're going to build on Monday. Do you think you did well on the tests? Did you show your work? Okay. If you didn't show your work, that's a problem.